is a variable. When an object, such as a float, is created in a Python program or using the Python shell, memory is allocated for it. The location of this memory within the computer's architecture is called its address. The actual value of an object's address isn't actually very useful in Python. But if you're curious, you can find it out by calling the id built-in method, which goes something like this: id. Here, this number refers to a specific location in the memory that this number is allocated. For anything beyond the most basic usage, it is necessary to store the objects that are involved in a calculation or algorithm and to be able to refer them by some convenient and meaningful name rather than an address in the memory. This is where variables come in. A variable name can be assigned or bound to any object and used to identify the object in future calculation. For example, a is equal to 3 and b is equal to negative zero point 0.5. Now when we multiply a and b, we get negative 1.5. Now let's look at the code. We create the integer object with the value 3 and then assign the variable name to it, which is a. Then we create a float object with the value negative 0.5 and assign the name b to it. Finally, the calculation, that is a into b, is carried out. The values of a and b are multiplied together and we get the result of negative 1.5. Now the result, negative 1.5, is not assigned to any variable. So after being output to the screen, it is thrown away. That is, the memory required to store the result, a float with the value negative 1.5, is allocated for long enough for it to be displayed to the user, but then it is gone. If we need the result for some subsequent calculation, we should assign it to another variable, like this. C is equal to a into b, then we print c. Now that our answer of negative 1.5 is stored in the variable c, this now can be used in a subsequent calculation and will not be forgotten by Python. Now there are some rules about variable names. The variable names are case sensitive, so a small a is different than a capital A. Variable names can contain any letter, the underscore character, and any digit. But keep in mind, these names must not start with a digit. A variable name must not be the same as one of the reserved keywords given on the screen. The built-in constant names, true and false, and none, cannot be assigned as variable names. A side note, it is possible to give a variable the same name as a built-in function, example abs and round. But that built-in function will no longer be available after such an assignment, so it is probably best avoided. Luckily, most have names that are unlikely to be chosen in practice. In addition to the rules mentioned earlier, there are certain style considerations that dictate good practice in naming variables. Variable names should be meaningful. For example, area is better than A, but not too long. The area of the triangle is unwieldy. Generally, don't use I, uppercase I, and lowercase l on the or the uppercase letter O. They look too much like the digit 1 and 0. The variable names I, j, and k are usually used as integer counters. Use lowercase names with words separated by underscores rather than camel case. For example, mean height with an underscore and not mean height with M and H as capital. Breaking these style rules will not in any way result in your program failing to run, but it might make it harder to maintain and debug.